All right, hello, math fans. All right, so this is day 3 of radicals, and what we're going to do today is basically division. Okay, with it's radicals with fractions. How we'll kind of call it that: radicals and fractions. All right, the most important rule that you guys will know. The most important rule is this. Okay, I'm going to put it in red because it's so important. No square roots in the denominator. Okay, I can't stress this enough. You will never have an answer that looks like this. 2 over the square root of 3. Or 5 over the square root of 7, or 8 over the square root of 6, or the square root of 7 over the square root of 3. Okay, this will never, ever, ever happen. If you have any answer with the square root in the bottom, it's wrong. I will just mark it. I'll put a big X through it, and it'll be wrong. Okay, so you have to remember that. I'm going to show you how to get rid of that radical, but you've got to keep that in your brain that there are no radicals that are allowed in the denominator. That is huge. Huge. Okay? Don't forget that. No radicals in the denominator. The top is fine. The square root of 7 over 3, the square root of 105 over 2. Those are all good. But 8 over the square root of 2? Nope. Wrong. Okay? So don't forget that. Alright. So let's talk about how we actually simplify these. Alright, this is the deal. If I have 2 over the square root of 3, and what I want to do is I want to get the radical out of there. So the only way to get rid of a radical, if you guys remember we did multiplication in yesterday's lesson, is if I multiply the square root of 3 times the square root of 3, what is that? What's the square root of 3 times the square root of 3? Isn't that just 3? Remember we learned that yesterday? So if I multiply the bottom by the square root of 3, well, I can't just multiply the bottom by the square root of 3, but what if I multiply the top and the bottom by the square root of 3? Am I changing the problem at all? Well, no, of course I'm not. Because don't you guys agree that this value right here, isn't that equal to 1? So if you multiply any number by 1, you haven't changed the problem at all. So that's what I want to do is you multiply the top and the bottom. So this is the rule. Rule 2, we call this rationalize. We already talked about rationalize the denominator. So rule to rationalize the denominator is basically you multiply the top and bottom by the bottom radical. That's it. Multiply the top and bottom by the bottom radical. Okay, so if I multiply the top, I get 2 square root of 3. If I multiply the bottom, I just get 3. And that, math fans, is actually my answer. 2 root 3 over 3. Okay, it's really pretty easy. You just got to follow those rules. Okay, let's try another one here. 8 over the square root of 5. Multiply by the square root of 5 over the square root of 5. I get 8 root 5 over 5. Okay, not bad. 2 square root of 3 over 7 square root of 5. Okay, again, I don't care about the 7 there. The 7 is important, but I'm only looking at the radical. Okay, I am only looking at this guy right here, math fans. That's it. Okay, nothing else. So that means I need to multiply the top and the bottom by root 5 over root 5. So that gives me 2 root 15, right? Root 3 times root 5 is root 15 over 7 times 5. So my answer is 2 root 15 over 35. Now guys, it's the same thing with multiplying. You can only multiply, just like when I told you 2 root 3 times 7 root 5. You multiply 2 times 7 is 14. And root 3 times root 5 is root 15. And that's my answer. I can only multiply things together inside the radical, together, all those together, and multiply all the stuff on the outside of the radicals together. So it's the same thing with division. You can only divide numbers that are under the radical together and then also numbers that are outside the radical. But before we even get into that, now that we understand how to rationalize the denominator, let's talk about what we can do. If I have the square root of a over b, I can write that as the square root of a over the square root of b. Okay? So in other words, if it's one big radical, each one of those I can give all by itself. I can take the square root of a and the square root of b. Same thing if I start out with the square root of a over the square root of b, I can write this as one big radical a over b and then simplify this if I need to. Okay? So let's just do a couple examples, but sometimes what you have to do is sometimes you have to write it as one fraction. Okay, so here's one fraction, this guy right here. Sometimes you need to split it up into two separate fractions. Okay, but remember, you can't have a radical in the denominator. That's the most important thing. All right, so if I did square root of 10 over the square root of 5, okay, as opposed to rationalizing the denominator here, why not write it as one fraction? Because if you write it as one fraction, watch. Square root of 10 over 5. Oh, cool. 10 over 5? That's just 2. So the answer is the square root of 2. Okay? Now, if you did this, if you went, oh, well, I need to rationalize it, and you said the square root of 5 over the square root of 5, and then you multiply the bottom, and you got 5, and the top, isn't that 10 is 5 times 2, and times 5? Oops. And then you could say, well, I could pull out a pair of 5s, so 5 root 2 on the outside and 5. That cancels out, and I have root 2. Well, which one was easier? Okay, this one was definitely easier. Okay, by understanding that you can write it as one fraction. Okay, let's try another one here. Square root of 7 over the square root of 14. Okay, well, again, I can multiply the top and the bottom by square root of 14 over square root of 14, but, you know, that's kind of large. So what if I just write this as square root of 7 over 14? Well, isn't that just 1/2? Now, you still have to rationalize it because, remember, you can't have a radical in the denominator. So I still need to write it as the square root of 1 over the square root of 2. Guys, do not ever, ever, ever leave a square root of 1. Okay, that's a really bad mistake because what is the square root of 1? It's a perfect square. It's just 1. So I can write this as 1 over root 2. Now I still have more work to do because I can't have the denominator in the bottom or radical in the bottom. So I'm going to multiply this by root 2 over root 2. That gives me root 2 over 2. Okay, I know it's a little bit of work there, but sometimes it's easier to simplify the fraction ahead of time. I can also have something like this. If I say the square root of 4 over 25. Well, can I simplify 4 over 25? No, I can't. It doesn't simplify. What I can do is I can write this as square root of 4 over square root of 25. And isn't the square root of 4 just 2? And isn't the square root of 25 just 5? And there's my answer. So sometimes it makes sense to split it up into separate terms. Okay, but I'll tell you, math fans, what you want to do always first is you want to simplify the fraction if you can. Okay, I would recommend that. Always simplify the fraction first. So here's another example. Square root of 2 over square root of 8. Well, there we go. Square root of 2 over 8. So isn't that the square root of 1/4? And look at that, man. I know those are perfect squares. Square root of 1 over square root of 4. So that's 1/2. And that's your final answer. Okay? Sometimes it's easier to simplify a radical. Like, let me give you an example. If I have 2 over the square root of over 75. Okay, I could multiply the top and bottom by root 75 over root 75. Now, I know, since obviously the 2 doesn't have a radical in it, but what I can do is, why not simplify this guy first? This is the deal, math fans. If you don't simplify it first, you're going to have to simplify it at the end anyway. So why not make it easy for yourselves and simplify it early before you start multiplying stuff out and making nastier numbers? So isn't 75 25 times 3? So I'm going to pull that out, and I get 2 over, I get a 5 root 3. Okay, now I rationalize. So root 3 over root 3. So you get 2 root 3 over 5 times 3. So 2 root 3 over 15. Okay, now this is a really bad thing to do. Remember I told you you could only simplify with terms under both radicals or both outside the radical. Okay, don't do this. This is a really bad thing to do. I'm going to do this in red. Don't try this at home. I'm a professional. Okay. Is to go, oh, well, that's a 1 and that's a 5. And say 2 root 1 over 5, which is 2/5. Okay, bad. Boo. Hey, don't do that. Okay, only radicals and radicals you can simplify, or no radical, outside the radical. All right? All right, so let's try a couple more here. 3 over root 27. Well, let's simplify that radical. Isn't that 9 times 3? And I could take out a 9. And I have 3 over 3 root 3. So now those cancel because they're both outside the radical, and I have 1 over root 3. Okay, if you leave it like that, you're going to lose your credit because you have a radical in the denominator. And you rationalize that by multiplying it by top and the bottom by root 3 over root 3. So you get root 3 over 3. All right. What about this one? Root 28 over root 7. Okay, what are you going to do first? See if you want to simplify that fraction. And sure enough, look at that, man. Sweet. That's just 4. Square root of 4 is 2. That's my final answer. Okay, not bad. What about the square root of 70 over the square root of 35? Okay, it's like if you try to multiply the top and bottom by root 35 or root 35, it's just nasty, and you guys will probably cry. Okay, but what I can do is 70 over 35. That's just 2. But it's the square root of 2. And don't just go, oh, well, it's, I can take the square root away. You can't take it away. If it's a perfect square, you could. If it was a square root of 4, you can make it just 2. But otherwise, you can't just take it away. Okay, what about 1 over the square root of 100? Well, isn't 100 perfect square? 1/10. Pretty mellow. Pretty mellow. Let's see. How about square root of 17 over the square root of 3? Okay, can't simplify that. Even if I put it together, 17 over 3 doesn't simplify. So I'm going to multiply the top and the bottom by square root of 3 over square root of 3. You just rationalize it. And I get 17 is not divisible by 3, so I know I'm not going to be able to pull anything out, and I just multiply 17 times 3, which is 51, and root 3 times root 3 is 3. That's it. Okay, what about 10 over the square root of 10? Well, rationalize it. Square root of 10 over the square root of 10. That gives me 10 root 10 over 10. 10's cancel, and I just have root 10. Okay? Not too bad. What if I have a fraction already kind of built into this thing? How about 2/3 square root of 45? Okay, well, it's almost like the old days. So 45 is 9 times 5. So I pull a 9 out. I get 2/3 times 3 over 1, and square root of 5 left over. And I can remember the cross cancel, so I get 2 root 5. Okay? So it's a lot of practice with these problems. 10 over square root of 2. Okay, rationalize. Multiply by square root of 2 over square root of 2. That gives me 10 square root of 2 over 2. That's a 5. That's a 1. So it's 5 root 2. Okay, it's not too bad. Not too bad at all. Yeah, you can do a couple more here. Square root of 18 over square root of 2. Okay, 18 over 2, which is square root of 9, which is 3. Sweet. 17 over the square root of 5. Well, let's just rationalize it. So I get 17 root 5 over 5. That's all I can do. Okay, please don't cross off the 5. One's under the radical and the other one's not. Don't just cross off that 5. All right? Anyway, I gave you a whole bunch of examples here of division, but remember, no radicals in the denominator, and you simplify the fraction if you can first, math fans. That's probably the best way to go. All right? Have a nice day. Goodbye.